Good morning. Welcome to episode number 2 of the Zoomtown experiment. For today's video, we're going to be taking a look at Zoomtown, the actual filming location for this experiment. There is an old philosophical question. Which came first, the chicken or the egg? In our case, the question could be, which should come first, the layout or the Zoomie, aka the robotic car? After a lot of work on this, in our case, the layout, or Zoomtown, really has to come first. Although, I had to have a really good idea how big the Zoomie would be in order to accommodate it. The relationship is important as it will define how much error in positioning the Zoomie can have. There's a lot of interrelational design elements between the Zoomie and, of course, Zoomtown itself. For example, most, if not all, line following projects I have seen has one or two destinations, such as a start or end. Many of the cool YouTube videos that you'll see with the racing competitions for line following, it's one robot on the course. The robot starts at one location, ends at one location, and doesn't need to go driving into parking spaces and backing out of them, or navigating four-way intersections and making turns of that sort. So there's a lot more to this than a typical line following example. Even with SLAM, simultaneous localization and mapping, typically in that methodology there are no restrictions as to where the robot can go as long as it doesn't hit a barrier. And barriers would be at an elevation or a height taller than the sensor, typically a LiDAR, on the robotic car. In our case, that isn't the most practical situation, and it isn't truly practical in the real world. Say, for example, you've got roads, sidewalks, ponds, and grassy yards or parks. Well, if any of those surfaces are below the surface, the car could go through that while it's scanning out and mapping the entire area. In the real world, that's really not a practical situation. Additional information would be needed in a SLAM type situation to define or restrict access to those areas, thus avoiding the lawns, the ponds, the sidewalks, the bike paths, etc. For construction of Zoomtown, I really had one good choice, and that was plywood. Plywood is available in many different sizes, thicknesses, etc., and it's relatively economical. It used to be much more economical prior to COVID. But nonetheless, it is a good material. It's easy to work with. Common hand tools can let you work with it. And in our case, most of what we will need to do on this is drill holes in it and drive screws into it, as well as paint it. And again, plywood lends itself nicely to that. I did pick a nicer form of plywood. It's called sanded plywood. So it has a better or a smoother surface that's a lot easier to work with, especially for our application. Now, at some point along the way in this experimentation, it is highly likely that I've made a lot of errors in judgment or mistakes in the layout, etc. So in the future, I do plan on having to recondition or fix some of the road surfaces per se, and perhaps add in other obstacles, landmarks, barriers, and who knows, maybe some hazards, etc. Just don't know where this experiment is going in the long run. But plywood does serve as a very nice background or subsurface for our experiment. Here are some of the considerations that I put into developing this layout. The cost of the material had to fit within the budget. As I've alluded to in several of the introductory videos, this overall experiment is probably going to cost between $1,000 and $2,000, probably closer to $2,000 US. So this is a rather expensive venture, so I really got to pay attention to costs because let's face it, even as good as YouTube is and as wonderful as all you people are, I would need a whole lot more viewers in order to cover the costs of this experiment. Size, that really is limited to the space available. I don't have a massive amount of space at my disposal, so I mapped out an area here in the electronics workshop that I could devote to this experiment for the next year or so. Size is also limited to the expected size of the Zoomy. Now here I kind of took a stab in the dark. I did as best I could figuring out what components need to go into the Zoomies, how big it will end up being, and that's my best guess. So based on that, I went through and created the layout as we see it now. Another really unusual limiting factor to size was how would I film this? If this layout was massive, how would I get a camera covering the whole layout? Because as we get into experiments, we want to see the whole surface or the whole Zoomtown to make sure that the little robotic cars are moving where they need to be and not crashing into each other. We don't want to miss any of that excitement. So what I had to do was do some testing with mock-ups and so forth to find placement for a camera and a location for it and the right kind of camera, meaning ideally as wide angle as I could get. Unfortunately, some of the more wide angle cameras created too much distortion and I didn't like that, so I kind of had to make a compromise. And this is the camera view that you'll be seeing when we get into the experimentation. As already mentioned, easily modified. That'll be very important as we get deeper into this experiment. The quantity of parking was a very crucial element in what I wanted for the experiment. The more spaces equals the more complexity for the whole process. If we only had a start and a stopping point, well, in truth, that's nothing more than a line following practice, and that would be rather boring. In our case, we're realistically looking at 15 to 16 Zoomy cars running around that could go to any one of the 30 or 32 parking spaces. So it's quite impressive with what we're putting in this small area. The quantity of roads was another big consideration for me to make this as close to a realistic type simulation as we can come up with. Very few towns, except for those wonderful little tiny quaint towns, have just one road going through them. So I wanted to mix it up with some turns, etc., to get from point A to point B. Just makes it a lot more interesting, and in truth, it gets it a little bit more similar to the real world of transportation. Here you can look at an overhead view of the layout as I designed it, and this design has stuck solid since May 23rd of 2023. Prior to this, there were probably about 10 to 20 other designs that I had penciled up and then put into CAD to see how it would work. But as you can see, for example, right here, there's a Zoomy, an outline of what I think the size of the Zoomy will be going around this turn. Nice graceful turn on our outer loop. That graceful turn is something that I really wanted to incorporate instead of just restricting us down to pivot turns. That'll make more sense later on. But you can imagine the car going around this way and another car going in the opposite direction on this two-lane roadway. Those are going to be very close to one another. So that is a critical aspect to the overall layout. I needed plenty of roads, but I couldn't have so many that that's all that existed. We'll go into a little more detail about other features on this, but just know this, there's two different types of parking places, where here they're nose to nose in we'll call it a long driveway with a barrier in the middle, and then over here are side-by-side driveways. And that'll, of course, make more sense too as we get a little further along. And I don't think too many cities should be without a city park, so I've included a park area in the layout. Now, answering and continue answering questions about just doing line following, this is an example of one of our four-way intersections. Now, if I were to just utilize line following and use that through the turns, this is how the intersection would be marked. So for example, if the car is moving from right to left and it comes to the intersection, it could make a right turn, which would be relatively easy to navigate, a left turn, which would be a nightmare to navigate across all those different lines, and even a straight pass through of the intersection would be a nightmare trying to keep track of which line to follow. No doubt it's possible, but boy, that would be an awful lot of coding for something that doesn't really need to be that complicated. Here are some of the specifications that I currently have. Again, I have to keep reinforcing the thought, nothing is solid throughout the entire duration of this experiment. But the length and width of the layout is 4 feet by 8 feet. That's a standard size sheet of plywood here in the United States. That would equate to 1.2 meters by 2.4 meters. All roadways are dark gray and 2 lanes wide, at a total width of 8 inches for the entire road width. 8 inches is equal to 203 millimeters. The lanes are half that width at 4 inches wide each, or 101 millimeters. Yellow center lines are on the layout, and they're a 1/4 inch wide, or about 6 millimeters. And they're really there just for us humans to reference left side of the road versus right side of the road. And yes, this will be right side driving for here in the United States. We'll be on the right side of the road, that is. Guidelines are what the line following uses, and those are 2 color, light gray and white. Total width is 0.65 inches, which is about 16 millimeters, and the white portion is a 1/4 inch wide right down the center of the light gray line, and that is a 1/4 inch wide at 6 millimeters. Side-by-side parking spaces are light gray and 4 1/4 inches wide and 4 1/4 inches long, or about 108 millimeters square. Nose-to-nose parking spaces are light gray and are 4 inches wide by 4.625 inches long, which equates to 101 millimeters by 117 millimeters long. Any of the grassy areas on the layout are painted green and are of various sizes, and those are forbidden zones. It will be a severe violation if a Zoomy drives across a grassy area. With the layout defined and constructed, it is time to turn our attention to the details of the Zoomy. There is a lot of design work and engineering that needs to go into it. In the next episode, we will look at the requirements for it. Thanks for watching, and I hope you join us again next week for episode number 3.